Yeah, so I think the three problems I want to start with are like, yeah, like email verification stuff, proof of personhood, and like verifying a person like is a person. Okay, so like when you have email leaks, right? There's like some like politician and the email leaks.
Yeah.
In the U.S. has happened like a number of candidates. It happened with the Italian like president. It
With
happened with like a bunch of
Hillary
people.
Clinton,
Um, so how do you like when that email leaked? Obviously, the person is like, no, this wasn't me. This wasn't my email. Like I promise I didn't send it. And then the press is like, no, how does WikiLeaks have like 10,000 emails? Obviously, somebody sent this email. It wasn't you. And they're like, no, that one got doctored by the Russian intelligence. That wasn't me. Like, okay, how do you figure out who's correct? Like, is the email real or not?
Can't you use ZK email?
You could, but even before ZK email, like what they're doing is there's like a specific piece of cryptography like on this email, which I don't know, this is like your little email, and then inside the email, like there's all the text, and then there's going to be like this verification header. And this verification header is gonna say like, like if I sent an email from like @gmail.com, like Google is going to put a header on this such that anybody can verify that Google in fact said that this email was sent. And then like 2 years later, someone can look and be like, oh, does this like verification header that Gmail put on this email check out? Yes or no? And only if Gmail like actually lied then, will this will the email not match? So you can think that like, okay, if I like
What does the header look like? Is it on every email?
yeah, why don't we pull it up? So okay, you want to go to your inbox? Not in your mobile, it has to be on a laptop.
Oh.
I think it's fine if you
Yeah.
have this.
Oh, okay.
Okay, cool, yeah, sweet. So this is exactly it. So this is like what's hidden behind all the emails you send and receive. So this is the actual email, and it's all this HTML stuff. And then in between, you'll see whatever text you can read in the email. Oh, here, right? This is like the text that was sent as part of the email. And then like this stuff at the top, like this is all this like weird verification header. And the specific one we are looking at is like this big crazy text. Like this big long string here is what we are going to verify. And like in the email leaks without ZK email, you can already look at this and be like, does the exact text of the email match this like cryptographic value? And then you can say, okay, if it matches, then it must have been sent. And Google, in fact, attests it was sent on like March 3rd or whatever.
Like, I think she needs context for hashing to.
Yeah. So what I was gonna do is I'm gonna say, okay, like the problem of verifying the emails, like, okay, now we need some sort of string that can be verified.
And like, where do I like to match it with?
Yeah. Okay. Great. So let's do that. So like I'm gonna try to like motivate the problem, and then we're gonna build it up. I'm gonna say, okay, like this is like these are the three pieces of infrastructure that are gonna get verified, and like, this is how each one works, and we're gonna build each one up. So like, okay, so what is gonna get verified? Like, so you got to explain a little bit of public key, private key stuff. Okay, so there's like a public key, and then there's going to be like this like signature of.
I know if you have a public key and private key together with that, you get a message. Is that what? Isn't that what you said?
Yeah, so if you sign like a message with your private key, it'll be like something random, and then if you take the public key and use that on like the private key,
and
then
then
the message, you'll get the message back.
Yeah.
And basically, the private key is obviously private, but everyone's public key is basically like listed somewhere or like stored in your computer. Basically, it's public.
Yeah.
And then the way you can check if someone is who they really say they are is you just match their public key.
And the message.
Yeah, and you can choose a message.
Private key.
No. So okay, so
Okay,
let me so what is a good way to explain this? Like okay, so if I have some private key and some public key, my goal is I want to say that like I have some information, and that I with this private key I'm going to say like I attest this information, and then anyone else can take like okay, so like I have all three of these, and you only have these two.
Okay.
And then now I'm gonna like, and also there's a message, sorry.
Yeah.
So, okay, I have all four, and you only have these three. Like, I am never going to give my private key to anybody.
Okay, yeah.
Somehow, with only these three, they need to say, my private key or my public key, like, I did something here that required my private key. Does that make sense? Like, so this person with these 3 is gonna verify me with these 4.
So the person with the 3 can somehow find your private key?
They cannot find the private key. There's no way to get the
He's
private
always
key.
like hidden.
The private
But
key is
your
hidden. This
public
is
key-
only me.
Okay, yeah.
So everybody in the world can see these 3,
Yeah.
but only I can see this one. And so the point is we need some kind of verification where like the rest of the world can verify like this, like, okay, I tested to this message without
okay.
having access to my private key.
Okay. That makes sense.
Yes. Okay. So now like what gmail.com is doing
Yeah.
is they're doing exactly this process. This message becomes like the email. This like signature becomes that long crazy string of like so like Gmail takes this message, they create this long crazy string of bits with Gmail's private key, and then everybody knows Gmail's public key. That's like on the internet infrastructure somewhere. And now when I want to verify the email, I take Gmail's public key, I take Gmail's signature, and I take the message, and I'm like, okay, yep, this is correct, this is wrong. This is how you like verify an email.
Makes kind of sense.
Okay. Yeah. So maybe.
So basically, because they don't have access to your private key, they have to make long strings of code.
Yes, they make long strings.
A signature.
A signature, exactly. Yeah.
Okay.
And then that signature, if you have the public key in the message, you can verify. Okay, this was signed by this like public key, even though I don't have the private key. Okay. Sweet. Okay, and then I guess some of the problems that they're solving is like around like very simple transaction stuff and proof of personhood stuff. So, okay, so imagine that I now want to like send you money.
Okay.
And I don't want to trust some like centralized service like Wise. Like I want to be the case that even if we're in like authoritarian regime, even if like, you know, I like, you know, no matter where this money comes from, like I'm gonna have this money and then you're gonna have this money.
Okay.
And there's gonna be no central third party we have to trust in the middle who might be able to freeze our accounts.
Okay.
How is that gonna work? Well, you could imagine you could use this like private key, public key thing, where like, okay, now like, okay, this is like, let's say this is Aisha state, and now this is gonna be Sandra state, and we're going to have, okay, and then you're gonna have your like C private key.
Okay.
C public key. Okay. So we're gonna do a very similar thing where like I'm going to say that like, okay, like I only know your public key and you only know my public key, but I know my private key and you know your private key.
Yeah.
So then like I'm going to do a transaction, and I'm going to explain how we do this in a second, where I send money from like my private public key to your public key.
And then I get it with like a string of messages, basically.
Yeah, you're gonna get some message with some signature, so you know it's from me.
Yeah.
And then now when you want to send that money, you're gonna do the exact same process where your private key is gonna sign it and then send it to somebody else.
Yeah.
Okay, so then like, what is
to send it to you, not to someone else.
or back to me or to anybody? Okay, cool. So then what is a like blockchain doing? A blockchain is just like, okay, we're gonna like collect like these like signatures. I'm gonna use quotes to represent like a signature. So this is gonna be like a bunch of signatures and a bunch of like messages. So this is gonna be like whatever like ACD, like whatever like some nonsense like you like are unable to parse these. And like all this blockchain is saying is that these public keys are doing something with these messages, and like this public key does something with this message, and like at the end our like new state is this, like our old balances are this and our new balances are this.
Yeah, and then it's like helping us do our transactions.
Sure. Okay, so then maybe like at the beginning, like I don't know, like you should go ahead.
Why do you say that the stuff in the brackets is blockchain?
So okay, so I'm gonna like, so this is like one block basically.
Okay,
One block is just a collection of a bunch of signatures and a bunch of messages. And then now like the next block is going to be like, and I can explain hashing in a second, but the next block is going to be like, okay, I'm gonna take like, we're gonna have some like state. So this is like Ayusha's public key. It's like whatever is $1. Like C's public key. It's like $0. And then like after this, now we're going to have like a new state where like A has $0 and C has $1. And this is gonna be because like I signed this message saying, okay, the message is maybe gonna send $1 to C, and then like anybody can look at this blockchain, see the message, they know our public keys, so they can verify the signature, and they can verify the message, and they can be like, yep, looks like $1 was sent from here to here. Okay, I agree. And so what this means is that now anybody can get like global consensus over the fact that like this value is now $1, because everybody in the world can take all the public keys, all the signatures, all the messages, verify that sequence, and be like, yep, at the end it was $1.
Yeah.
And so that's exactly what a blockchain is. Instead of doing this on one message, you now do it on like a million machines. Instead of doing this on one machine, you do it on a million machines. And a million machines are all going to keep all these signatures and all these messages and check like, yep, the state is now $1. I'm verifying these signatures. Yep, that is correct. And so.
Who's verifying this?
Huh?
Like, well, why are these machines verifying them, and for whose machines are they?
Yeah, so these are like, in blockchain, this is like validator nodes. So these are going to be like people who sign up to say, keep all this data and verify all these changes. And then at the end of the day, they get paid like a little bit of money. They get paid Bitcoin or Ethereum or whatever.
Why are they verifying them?
They're verifying them because they think like the states that are being represented in these like balances are important for some reason. That they think that like, okay, it's important, huh?
Oh, it might be like fraud or something.
Exactly. They're verifying that there's no fraud happening.
Oh, okay.
That like this value at the end is the same.
Okay.
And like, okay, for Bitcoin, it was like, okay, we can transact money now. Because everybody, like, as long as these like 1,000 machines say that we all transacted the money, like, we can all believe that we transacted the money, and you can verify I transacted the money. Like, you, like Cassandra, can look at these and verify, yep, in fact, I did get the money. And I, Ayush, can be like, yep, okay, these signatures check out, yep, in fact, the money got sent. And so everybody can verify it, including you and me. Versus with a bank, we used to trust what the bank says. There's only one bank machine, and the bank machine might lie, and like, the bank machine might freeze my money.
So with your signature message, you can verify your public key and the message? Why is the signature of message and the message two different things?
So this is two different things because a message is like human readable, and the signature of message is not human readable.
Okay.
So the message might be like send $1 to.
So with the signature of message, you can get you can verify the person's public key.
You can.
Is
so
it interchangeable?
So this is okay. So this signature. Okay, I'm trying to think if there's like if we can put together like a specific sequence of numbers that makes it very clear. But I think it's very hard to come up with like an obvious one-way function that's like intuitive. We could do like, yeah, it's tricky. All this stuff requires like modular arithmetic or like some annoying mathematical primitive. Like the signature is like, you can imagine it being like some combination of like the private key and the message that is verified with the public key.
Okay.
So like maybe my private key is like 010, the message is like CA $1. Okay, $1 is a bad thing. Let's say like CA1, and then like the signature is like, I don't know, I like add these two things together or something. It's now I get like CB1 or something. And so like, this is a bad example because from the signature and the message you can get back my private key, but maybe this is like more confusing then, but imagine this was like some random sequence of like, I don't know, this was like 6, 7, 8. And then now the signature is going to be like some other junk, like C plus 6 is like whatever, what is the 9th letter of the alphabet,
that
like,
makes sense.
or I or something, and then it's going to be like some other character. And the idea is that there's some algorithm where if you do this with like a bunch of mathematical machinery, you cannot get back this secret key. And so, so the point of a signature of a message is to verify that a public key has attested to some message. Okay, sweet. Great. My signatures are important. Okay, so this is like blockchains. This is like signatures. This is like emails. Okay, and then I think okay, maybe one good question, like one good litmus test here, which is like tricky, is okay, why might this be different than encryption? I guess maybe should I explain encryption first?
Yeah.
Okay, so problem is encryption is not very relevant to this, like anything we're doing, but I guess I'll explain it anyways. So the point of encryption is that like Like, so here all the communication is public. Like
Yeah.
every message and every signature message is
Yeah.
completely public.
Yeah.
Like everybody in the world can go verify, and that's
Yeah.
like the property here.
Yeah.
And then encryption is like if you want some, it's like the first layer of privacy. So it's kind of, okay, like A and C want to communicate. They want to send a message that's not public, but that only A and C can see.
Okay, yeah.
So now what I'm gonna do is I'm gonna like
They
take,
make their own like style, I don't know, like language. All I read on Isha's slide was it started in Egyptian times. Is that right?
Yeah, but I mean, that's not really
relevant?
You
Is that
can
not
ignore,
relevant?
you can ignore that. That was
Okay.
just like the history. I showed her like my first year, like my introduction to cryptography slides,
Yeah.
and they were talking about like ancient like ciphers before like everything else. So it's not just
Yeah.
just ignore that for this.
Oh, okay.
I would say like real encryption existed in World War II with like Alan Turing type stuff.
So they make up their like own language, so people can't figure it out.
Basically, yeah,
Okay.
that's exactly what it is. Like they're gonna map like every word to like a different word,
Mhm.
such that only like A and C know the secret
Yeah.
language. Exactly. Okay, perfect. So, and okay, like how does this relate to private key, public key, signatures, messages? Like this secret language is a combination of our private keys. And so, how does this work? Like from my private key and C's public key, and from my public key and C's private key, these like give the same value when you combine them together. So if I like combine these two and these two, they're the same value. And that means me, with only my private key and C's public key, I can generate our like secret language. And C, with only your private key and my public key, you can generate the secret language. And so now we both have this like shared channel with this shared secret language. Exactly. And now we can converse over this. Okay, now here's a question. Why can't like Isha, like why can't E see these values?
Well, because E doesn't have private key of A or public key of C.
Private key of C.
Yeah.
She has public key of C.
Okay, if she has public key of A and C, she doesn't have. But didn't she say that? Oh, okay, yeah. Wait, no, I don't get it.
Go for it.
I don't get it, cause the arrows are pointing this way, so.
So you need to combine one public key and one private key to get the like.
Yeah, so
Encryption channel.
shouldn't E be able to do it if they had the private key of A and public key of C?
Sure, but E does not have the private key of A, right? Only I have my private key.
Oh, okay, yeah, good point.
Yes.
Good
Okay.
point.
And then only you have C's private key, and she doesn't
Okay.
have.
Okay, yeah, that's why I can't do it, cause they only have the public keys of.
Mhm.
Yeah.
Right. They don't have the public keys, so they can't construct this like channel.
Hmm.
Okay. Sweet. Okay. So now encryption is for like two people to communicate privately. Right. Okay, I wonder if there's anything else you should explain with signatures. Okay, I think that's. I wonder if we should explain hashing.
I think you should just go for the fact that every time you have like one input, it always produces the same output, and like changing anything in the input completely changes the output.
For hashing?
Yeah.
That
You
probably
don't have
help.
to get into anything else of hashing.
That
I
would
think.
probably help with the second website with this
Twitter.
proof of email.
Oh.
Would it? Cause
Like a,
isn't there input and output something like that in it? Or no?
not for that, but like I do think hashing is
Okay.
relevant like for everything.
Great. So let's do hashing. Great. Okay, so there's a bunch of algorithms in this like hashing category. The most common one is this thing called like SHA-256. There's like they all have these like weird long like fancy names. Like there's one called Poseidon. There's one called like reinforced concrete. There's like lots of random shit. And like okay, what are these hashing algorithms doing? Yeah, it's the idea that you have some like long string, like I don't know, like what is like a good secret string to hash? Like maybe like the password is like 1, 2, 3, 4 or something. This is the like thing I want to hash.
Is that like code basically, and you have to decrypt it? Is that what hashing is?
Hashing decrypted.
Like, so like this is like a secret word, and then you just have to like figure out what actually is supposed to be saying through that.
No, I don't think so for that.
Oh, okay. Then what is hashing?
Yeah, so I would say decrypting and encrypting, like this is the process that's happening here.
Okay.
So we construct like this shared value, and then A will encrypt a message, like A will speak in the secret language, and then when C reads that secret language and converts it back to English, that's like decrypting. So I would say encrypting and decrypting is very specific to encryption, and hashing is like sort of a separate thing. So hashing is the idea you can just like hide information in a way that you like commit to this. Like, okay, what is like SHA-256 actually doing? It's basically taking like, okay, it's gonna split it 8 letters at a time, like around like 4 letters, and it's gonna be blank, and then they're gonna like shuffle it up. So like what it's actually doing is gonna say, okay, T, and then plus P, and then like times like E, and
I
then
feel
like
like
minus.
going into that isn't like as relevant. You could just maybe explain like what happens to like the input and if you change it.
Yeah,
I don't
yeah.
think, I think this would be more confusing. Like,
Sure,
the
okay.
specifics of hashing.
Okay, yeah, that sounds good. So I guess like the general thing that's happening is like I'm going to take like a random sequence of like arithmetic combinations that like looks pretty random, but it's always going to be like an addition there, and a multiplication there, and like an addition there, whatever. And like at the end, I'm then going to get like something that looks like basically random, like okay, whatever. And then because like okay, so this value is maybe like that value times this value minus this value. Like it's like some random combination of these letters combined, and same with this, same with this, same with this.
Yeah.
And the interesting thing with this is that if I change one letter here, like if this E becomes like, I don't know, like an A, then like every single value changes.
Yeah.
Because this value is like, you know, T plus H minus A
So
times
that's the
P, whatever.
input, and that's the output.
Yeah.
Okay.
Yeah, sorry.
And importantly, like you can't predict the change of it.
formula?
Yeah, you can't predict what's gonna happen by changing like one thing. The output will be like if you change, even if you add like a space or like a dot or whatever, the output will be so random like that. There's no way, like there's no specific formula that someone could look at the output and be like that's the input.
Okay.
And it's also because
So you can't find the formula.
You can't find
So
the formula.
so the formula is public. So the formula is like, you know, it's gonna be like T plus B like to the power of E times. It's like gonna be some crazy long
Yeah.
thing,
Okay.
such that like.
Public.
Yeah, but the reason that like if someone just gives you the output, you can't necessarily like derive back the input without like some hints, is because usually the output is like a fixed size and the input could be anything. Like it could be like what we saw, like the thing of an email, or it could literally be like a space. And it will always, the output will always be a fixed size, and because just by logic of like if the thing is
Let's
fixed,
say that someone doesn't have the formula, and they just have the output, so they can't get the input because it's just like.
So everybody has a formula. Everybody knows the formula of SHA-256. But this formula is very hard to reverse. Like it's a very complex sequence. It's like a lot of addition and a lot of multiplication, a lot of exponentiation, and a lot of like long mathematical things. And so you can calculate it. If you have this, you can calculate that long mathematical thing. But you can't reverse engineer it.
yeah, so it's easy to go from like your
From
input to your output.
Yeah,
But it's really hard to go from your output to your input, and the reason because of that is because your output is a fixed size,
okay.
whereas your input could be anything. And then there's sometimes like, for some inputs you might have,
Even if you have the formula, it's hard for you to get the input using the output and the formula?
yeah.
Yes.
Okay.
And it's because the formula is such a long, complex sequence of mathematical operations that
Okay.
reversing it is like impossible.
Okay.
And it's impossible because there's like, people have $1 billion where it's like, I'm gonna put $1 billion here, and if you can reverse this hash, you can get this $1 billion
Why do we
back.
need an input and an output?
Okay, so the idea is, okay, why do we want hashing?
Yeah.
Okay, there's a couple of reasons. One is that, remember this like signature message thing? If I went and I signed like 1,000 character email, that would take forever. But if I reduce this 1,000 characters to some like, I don't know, 256 characters, or in this case, 4 characters in this example, then like the signature can be much shorter. That's one thing. The second thing is that this is like kind of like a commitment to the message. Like I can say like, okay, like this is my password, and it's like, you know, the password is 1234, and then like when I come back to the website and I put in this password again, the website just checks, okay, if I hash that, do I get 0AB2? And the website didn't learn your password. The website only like checked the hash and like does the hash match. And this means that like this value is still unique. Like somebody has to know exactly this string. Like this is my password, right? Someone has to know exactly this string to be able to log into my account. So like every website you go to in its database, it's storing not your password, it's storing hash of your username and your password. And so only if somebody knows your username and your password, they can get this value out. And this is what's in the website's database.
The output.
The output is in the website's
The
database.
input is made out of your password and your username.
Yeah, usually for websites.
And the output is like what?
Just the
Something
hash.
random.
So that output is going to be like, I'm going to run this like crazy mathematical function on all these letters. I'm going to combine them. It's like,
So once I put
yeah.
in my like username and password,
Mhm.
then it runs. I mean, like it just like logs me in.
so how is it logging you in? It's calculating this hash locally.
Oh.
So this is going to get calculated in your browser. It's going to get sent to the server. Server's going to be like, is that hash match? Yes or no? It matches.
matches.
Cool, log them in. It doesn't?
Ah.
Okay, it's not Cassandra, or she forgot her password. Don't log her in.
So the output is like a hash thing and it has to match.
Yeah.
Okay.
Okay. Sweet. Cool.
That was a good explanation. The ending that made things better.
Yeah,
Yeah.
the username and password thing is nice. And that the other advantage there is that the website doesn't actually learn your password, which is like the important reason that you want this to be like completely like you can never go backward, or else the website would know your password, and that's no good. Sweet. Okay. Hashing. Ethereum smart contracts. Okay. Yeah, we could do that. Okay, so. Okay, so imagine here. So like this process that I just described, of the amounts of money changing,
Yeah.
is like effectively what Bitcoin is. Like Bitcoin is saying
Oh,
like
yeah,
this is
yeah.
everybody's balance. This is everybody's balance now. And
Yeah,
this is what
and
the difference was.
You can't like do like fraud because like things on Bitcoin. No, that's the blockchain. But yeah. Sorry, I get them interchanged.
So maybe this is a good description. Is like blockchain is the category of
Yeah.
things that look like blockchain. So Bitcoin is the first blockchain, and then Ethereum has a slightly different like blockchain
Are
like a
they
design space.
currencies?
They're also currencies. This is
Oh,
a
okay.
confusing piece of nomenclature. It's like
Oh,
Bitcoin is both the name for this like the Bitcoin protocol, which is
okay.
like this like signing messages, sequence of things, lots of computer states,
yeah.
and the currency that is given to people like this person at the
Okay.
end is gonna get like some amount of money. Like
yeah.
this literal computer will get money for validating it was correct, and like that currency that computer received is also called Bitcoin. And so, yeah, that is annoying. Okay, so then out of blockchains, like the first one was Bitcoin in like 2008, and then Ethereum came like 2014 or
Okay,
something,
yeah.
and then there was like a bunch of more like
Yeah.
new different blockchains. These are all types of blockchains.
Yeah.
Okay, yeah, it's definitely also annoying that they both begin with B because it's very like confusing. Okay, right. So what is the difference between Bitcoin and Ethereum? Like, why do we use Ethereum and not like
Yeah.
Bitcoin? Is like okay, Bitcoin just handles like the amount of money,
Yeah.
and then Ethereum handles like more complex state. So here, okay, so how is this going to change with Ethereum? We're going to keep the messages, we're going to keep the signatures, we're going to keep the public-private key. But instead of this being A's public key and C's public key, it's going to be A's public key, C's public key, and also like the value stored at like what is a good thing here? Like maybe like Cassandra's hash or something. It's like C is like actually this is maybe a bad one. What is another thing? Like okay, like the address of like the co-working space. And this is gonna be like some string, like whatever, like Hankyou station. Or Osaka station, right? Okay, Osaka station. And like what this means is that I can no longer, like it's no longer the case I can only write numbers to public keys. I can write like arbitrary data to like arbitrary data fields. Okay, and the other thing is that the computation happening here is like money transferring in Bitcoin. Like in Bitcoin, it's just like, okay, this is gonna go down, this is gonna go up. And on Ethereum, it's like this state is going to change. Like on Ethereum, I can say, update this address to the new address. Like the new address is gonna be like floor 26 or something.
And Bitcoin isn't constantly updating, but Ethereum is.
Like Bitcoin is only updating like people's
Updating.
public keys and the amount of money they have.
Okay.
And Ethereum is going to update like any data to any other data via any arbitrary rules. So like another cool thing Ethereum could do is they could say, oh, like how many like number of people in co-working, and it's going to start at like 2, and then you can have logic in Ethereum that's like.
Why would you? For what reason would you use Ethereum like to change like my address on what?
So this is like a very simple like example, but we're gonna use this like it turns out if you are able to access any data and change any data, you can build like an entire internet, basically. And like how do we do this?
Give me an example of why I would use Ethereum and change what?
Yes. Okay. So like one example here is like imagine the number of people allowed into the co-working space.
Okay.
So it's like 2, and then I'm also gonna say okay now like anybody that A sends money to is gonna be allowed to the co-working space, and I'm gonna like program this into the blockchain. So I'm gonna say look like the rule for a number of people is going to be like A sends money.
To people. And
So I'm gonna define this rule. And then now, if A sends C money, then this is automatically going to become 3 down here.
Yeah.
And this will happen without anybody editing anything. It'll just happen in the background on Ethereum blockchain.
Okay.
And so, you know, all these...
You could take that and do what?
Like, you could build completely random rules. So now you could say, like, okay, the number of people are going to update when A sends them money, but also we're going to do a thing where, like, oh, like, will the law pass? Okay, like, is this law going to pass? This is like blockchain voting. Like, okay, the law is only going to pass if the number of votes that A sent is more than the number of votes that C sent or something. And now we can do like blockchain voting. So this is like, okay, like whatever, like 5 votes for yes, and like 4 for no, and then whatever, like something gets triggered. Like maybe like some money goes from like A to C or something. So like the point is you can now build arbitrarily complex rules. You can say like, and these are going to be coded in the chain. Like nobody can change this. It's just going to be okay. Like if A sends money to somebody, it's going to happen. And then like if A votes and C votes and then E votes and like other A votes, then like okay, now we're going to get like something happening. Like we're going to get this tally at the end and then something.
Ethereum protocol.
So these are Ethereum protocols.
Okay.
Exactly. So a protocol is just like a set of rules you're going to deploy to Ethereum, and they're going to trigger every time based on the same rules. And so like, okay, like what is the point of a DAO? Like a DAO's whole thesis is like, this is compelling notion. Like all of us are going to have money and we're all going to have voting power. And based on how much money we have, we're going to have different amounts of voting power, and that's going to trigger something interesting. And like people can buy and sell voting power by buying and selling NFTs or moving money around, and like, okay, this is like DAO's whole thesis. In my opinion, is like not that interesting of a thesis. Like, okay, like we could do this before DAO. Like what did the DAO give us? Like not that much. So, but okay, there are admittedly some new things from DAOs, which is like this is completely transferable. Like I can now put a price on my membership in the DAO, and someone else can buy that membership at a price. And in my opinion, okay, adding prices to things isn't always great. Like something shouldn't be like priced, but like okay, this is like the whole thesis of the DAO. Is like this like voting with this like these rules on the blockchain is like interesting. Okay. Maybe yeah. Do you wanna?
Like, the difference between just like regular Bitcoin and like what Ethereum enables is you can run code, and you can program different things, and you can create smart contracts where you can be sure that the code doesn't change, and that's like the thing.
What's a smart contract mean?
It's basically the code that you put on the blockchain that everyone can see, and you can make sure it doesn't change, and then you can actually assign like variables and whatnot. Like you can make assignments to things like the number of people in the co-working space, and everyone can check that, okay, like this is actually running the way it's supposed to. And the biggest difference is just that you can actually do the assignments. Like
You can like lock it. I think we talked about this before. Like the rules. Can you change it?
you can lock the rules of the
Yeah.
of the code. Yeah.
Yeah, but can you change it?
I think for this, like, it's best to think no for like.
So it's like a contract. You're setting a
Yeah.
contract. Is there an end time?
You can set one if you
can
want.
set one.
You like these are
Okay.
completely random rules. You can say
The
like
idea is you can program anything, kind of, or like most things with this. Yeah.
And you can set rules. Okay, makes
Yeah.
sense.
Rules that.
And that ties in with Ethereum protocol. How is that the same thing?
So smart contracts are like pieces of code running on like the Ethereum protocol. So the Ethereum protocol, like okay, so the Ethereum blockchain is gonna say all this stuff, and these balances are going to be like they can be in Ethereum, they can be in other currencies. Ethereum blockchain is the idea that all of these like nodes are going to run all this code.
Yeah.
What is the code they're running? It's smart contracts.
Okay.
And so like these rules that people define, like in this case, I define this new rule. Okay, now like every computer on Ethereum is gonna run that rule.
So the rules are called smart contracts.
Correct.
Okay.
Yes.
That makes sense.
Great. Okay. Sorry, that was a lot.
It's okay. It's
Okay, maybe
quite interesting.
Okay, maybe let's do like some space repetition here. Okay. Okay, here. Okay. Why can't E come in and like vote on behalf of C? Like, why can't E just steal C's vote and say, actually, C, I'm gonna send all your money to A, and then C like has no control and C just loses all their money? Like, what is stopping like Isha from taking your money on Ethereum or voting for you on
I
Ethereum?
have like $0.
Okay, sorry, my money. What is stopping Isha from taking my $1 on Ethereum and using it to like vote on the smart contract?
Doesn't have like your private key or like login, like
Correct. She doesn't have my private key, and so
Yeah.
she can't create a what?
Message.
Okay, so message could be something like A votes yes or A
signature
votes no.
of message.
Correct. She can't create my signature
Yeah.
because she doesn't have my private key.
Yeah.
Great. Okay, we've tied it all together.
Yay.
Maybe
Wonderful.
like super quickly also just adding like addresses, like the addresses are like your public key and like this.
Yes. Okay. So like that's a good point. So okay, what does your private key and public key like concretely look like? Your private key. Oh, good.
Or you can chat.
Yes. So
Oh.
I personally can pull up like my blockchain account and I can look at my private key, and my private key looks something like this might look like 0xACD054 whatever. Like, these are going to be like numbers from 0 to 9.
Someone steals your private key somehow. What will happen?
They can do anything. They can take all your money. They can do everything they want. So this is why we have like wallets. So I'm gonna have like a wallet in my like browser, and it's gonna keep this like 64 character public key for me, or however long your public key is. It's like how long is it? I think 64 characters like sound roughly correct. It might be 32. Anyways, it's 32. It's gonna be 32 character public key. Oh, wait, 32 times 4. No, sorry, it's a 64 character public key. It doesn't matter, but for everybody, it's gonna be a 64 character public key with the like numbers 0 through 9 and letters A through F. And yeah, if this gets lost, everything's lost, which is why like blockchain hacks and stuff are so scary, because if you like give your private key to somebody, it's over.
Mr. Reese had his Mr. Reese had his private key and public key on his laptop here, and then someone like raided his house, but they didn't see it.
Vaguely remember that.
That's my earliest memory of this. I just wanted to say.
Yeah. Okay, and then your public key is going to similarly look like this thing, but 40 characters long. So it's gonna look A through F and 0x like whatever, another like set of random characters. It's gonna be 40 characters long. Okay.
Can we tie this back to ZK email? And
Yes.
ZK
Okay.
email?
So I think we've done the basics. Okay. ZK email. I wonder if the way we should do this is I explain the high level of ZK email, and then we go into what is ZK and how do we actually get the ZK property on ZK email.
Okay, I think ZK email, I just think of it as an open source library thing, like my P5JS library that we use in CS class, and then that like devs can use to create tools.
Right. Okay. So that is the thing that we are showing to users and devs, but like under the hood, what is ZK email doing? Like under the hood. Okay. So remember this like Hillary Clinton email, like this like political email that we wanted to verify came from this person. It's gonna have like whatever, like a to, a from, like a body.
ZK email takes the header.
Yeah. So this is gonna be like this random like AF0 whatever. This is going to be our like header.
Does it take the header and then Gmail and then does something with it?
Yeah, so we're gonna take this like this header. So okay, this header is a signature. Remember this?
Yeah.
So this is gonna be a signature on this like message with like Gmail and Gmail's public key. So Gmail's public key. Gmail pub key is going to be like 0xA. Okay, so everybody has Gmail's public key, and Gmail is gonna like. When this email was sent from somebody with a Gmail account, Gmail generated a signature. Okay, so now I'm worried about erasing stuff.
Is there another side?
There is. We can use this actually.
Oh,
Perfect.
yeah.
Okay, great. Okay.
Oh.
Yeah, so I'll check this. sweet.
Sorry.
What's up?
No.
Okay, so let me copy that email here. Do
What's that say?
this is just AF0. There's like some random
No, like
sequence.
signature and hexadecimal?
Sorry, signature and header.
Oh, sorry. Okay.
Yep, and then
So the signature and header is that thing that we saw on Isha's computer.
yes,
Okay.
those like 64,
Yeah,
like
yeah,
lots and
I
lots of random
remember.
characters.
Yeah.
464 email signature. We're gonna have like Gmail's public key. Okay, this is gonna be some other like 0x54a. Okay, great. Okay, so the signature and header is going to basically say Gmail has taken Gmail's private key and this message, or this like message from down here, and they've created this signature.
Mm-hmm,
And this signature attests to all this information from Gmail. There's also going to be like a timestamp.
Okay, yeah, makes sense.
And so what this means is like you must have had Gmail's private key to create the signature, and I, like the rest of the world, okay, so let's say like I'm gonna put like Gmail's private secret key.
Okay, the rest of the world, if they take the signature header and they take that, how can they prove that it was actually real and that happened?
Right, so we're gonna do that exact same thing, right? So Gmail on this side, like literally like the people at Google are going to have like these values.
Yeah.
And now like I, the like recipient of this email,
Yeah.
so let's say this is from like, okay, be@gmail.com. Sorry, let me swap these really quick. This is gonna be from A to B. Okay, and now like rest of world, but mostly B. So like, okay, like most of the people who are looking at this email are just gonna be B, right? Like no one else is looking at your email. So B is going to take the email, and they're going to take the signature, and they're going to take Gmail's public key, and they're going to be like, okay, like, did Gmail use a signature to actually say that this message?
Wait.
Sorry, go ahead.
Wait, hold on. Okay, so if Gmail sent all of that to B,
Mhm.
and B receives the email, can B see the signature in the header?
Yes, because we just saw that, right? The email that we
and
received.
then public Gmail's public. What does it say?
Public key.
Oh,
Sorry,
public
my
key.
handwriting's
It's
not very
okay.
good.
Oh, okay, yeah, that makes sense. But they can't see Gmail's private key.
Yeah.
Correct.
Yeah, is that the first thing? What's
Yes, that is Gmail's private key.
Oh,
Sorry,
okay.
my handwriting.
It's okay. It's okay. Yeah. Okay. And then.
Okay. Yes.
So then what? So then like, what's next?
So what is next is B is going to say like, is this spam or not? They're gonna say, okay, like, it looks like Gmail created a signature that A sent me an email, and I can verify the Gmail's public key. So okay, this looks legit. This wasn't a spoofed email. I'm gonna now accept it into my inbox.
That's cool.
This is how spam prevention
I
works.
didn't know about that.
Yeah. So this is how like all emails ensure the email that they got sent from actually sent that email.
Wait, so why does things go into spam or like trash?
So things go into spam and trash. So
Maybe.
okay.
But I don't think we need to know that.
Well, things go into spam just because like some AI algorithms running on Google servers saying like, does the body contain a crypto scam? Like, do they have the words like,
Okay.
please send money to a Nigerian prince, like yes or no? And if it says yes, then it throws it in spam, and no, then it keeps it in your inbox. Yeah.
Okay.
But they're also doing the signature verification behind the scenes. You just don't see it because that email will never show up in your inbox. Yep. Okay, sweet. So what do?
Yes.
We hijack this for our own purposes.
Yes.
So we say, okay, the signature is useful for spam prevention, but it is also useful to prove things about this email. So what I can do now is I can go ahead and redact some information. Maybe the subject is like, sending you $5.
Maybe
like,
to like the proof of Twitter example, because
let's do proof of Twitter. All right. Great. Let me. Where's the eraser? Somewhere here. Great. Let's do Twitter. Okay. So, okay, when Twitter sends you an email.
Yes.
Okay, let's like rewrite this for Twitter. So tell me what I should change on the board for Twitter sending. Like imb@gmail.com and Twitter sending me an email. Like what needs to change here?
Gmail@twitter.com.
Yeah. Okay. So this is gonna be twitter.com. It's gonna be like.
B stays B.
Yep. This is gonna be login at twitter.com. This is gonna be like we do password reset email, but you can do any email actually. So it can be like notification, and then your body is going to have like some stuff, and then this email is for like my Twitter handle. Okay, great, and then like some stuff. Okay, this is gonna be the body of the email. Great, and then okay, these are going to be Twitter's private and public key. Okay, and these are obviously going to change. So for each new email, I mean Twitter's private key stays the same for 6 months at a time, so it's gonna be, I don't know, 80 something 04. I'm just gonna make up some random. Okay, great. So again, we're gonna have these like 64 character strings, or maybe more in this case. Signature, public key, private key. Great. So now when I receive this email, like I'm gonna do the same process. I'm gonna verify the signature came from Twitter's public key, and then I'm gonna be like, yep, this email looks legit. It did in fact come from twitter.com. Okay, sweet. Okay.
What makes ZK email different if we're doing the same thing as?
So what makes ZK email different is that I can redact information. So now I can go through and be like, okay, I want to prove. Okay, so I'm gonna do two things. So one, I'm gonna redact, and two, I'm gonna do this on chain. Okay, so remember that rule system we had? Like imagine I want to define a rule, which is like the owner of the Twitter username, like, okay, new rule, like @ushg is going to like be able to vote here. So like can vote. Okay, so now how this is gonna happen is, okay, I need to prove I'm ushg to the blockchain, and then I need to do my vote. So how do I prove I'm ushg to the blockchain? You can't log into Twitter on a blockchain. Like, these are mathematical rules. Right? These are like some money is sent, some state is something. You can't like call the Twitter API from a blockchain. So what do you do instead? You have to like hijack this like.
Does the rule thing relate to 1 or 2?
2.
Okay.
Sorry, my handwriting is exceedingly bad.
So if you set rules and then you they apply, then what?
Right. So okay. So what do I want to do is, okay, without ZK email, you can get this on-chain thing by doing this verification process on-chain. Right? You can just run exactly this email verification. Say, was that username ushg? And then I provide this email to the blockchain, and then now I do stuff. Here's the problem. I don't want the blockchain to know that my email is b@gmail.com. So what I want to do is I want to go in here and I want to like redact this. I want to say like.
That's like the core thing.
It's gonna look like this. Okay. And so this is gonna allow me to get this like redacted email on chain. Now here's the problem. Remember, like, what are the criteria for satisfying the signature? For this person verifying the signature, they need to have the whole message, and they can verify with a public key that Twitter generated this signature. Right? But now I don't have the message anymore.
Okay, yeah. So I know that the slogan for ZK email is like, we don't need to know about you. What was it? Something about, I don't need to know much about you to know about me. Wasn't it something like that?
Oh, you don't need to trust us.
Oh yeah, something like that. Yeah. Okay, so let's say they don't share their Gmail with us, or who they're sending who they're sending it to.
Yeah.
How can we figure out that?
Yes. Okay.
And
Great
help
question.
them?
So now what this person is, okay, so in like the case where we only do on-chain, like user B is going to send this email like unchanged like to this blockchain. And then they're going to like, this is going to trigger something. But now what user B can do is they can like stick ZK email in the middle. ZK email.
Mm-hmm.
Okay. And then what's going to happen here is ZK email's whole like cool thing is like we spent like a bunch of months and we built like a bunch of crazy cryptographic tech. And what it lets you do is like verify this redacted email with the signature even if part of the message is missing. So I can say like, okay, like we're going to take in, like ZK email is going to take in like Twitter's public key,
email,
the signature, the like original message.
but it's kind of like half.
Yeah, and like, so ZK email is gonna, so what like?
Mainly because you have the signature in the header, and that's why you can fill in the gaps.
Right, exactly.
Yeah.
So like ZK email can take in like all this information,
Yeah.
and notably like the code that B is gonna run will have the full original email, and then at the end, the output of ZK email is going to be like a ZK proof, which you can think of as like another long sequence of characters. And then like, let's say here we're gonna have Twitter's public key. And then like username. So, okay, like username. And then we're going to have like, so like when I output this username, I'm going to redact actually this entire email except for my username. I'm gonna get rid of this, I'm gonna get rid of this, I'm gonna get rid of this, but I'm gonna leave at twitter.com. And then I'm only going to leave at twitter.com and use Gmail. So that's going to be this. And so this will say twitter.com. These are gonna be the only two pieces of information. I'm gonna redact everything else. And the whole point of ZK email is that now, like from this new string, which is not a signature, it's now a ZK proof, even though it looks very similar, just another sequence of long random characters. Now this can be verified on the blockchain. And I can take a ZK proof on the blockchain with this redacted information, and I do exactly the same sequence, where I can say, the person who can prove to me they own at UG can vote now.
Can this be used in the wrong way, where you know someone send an email to someone and you kind of know some things, and then you can figure out like what they said?
Okay, great idea. Like
the E, like the C and I mean A and C, and then like E comes in and E wants to know about like what A sent C, and has like A's like email and like, so can it figure it out?
Can E figure it out? Sort of. So if E had this signature, they would be able to figure it out. So if E like somehow obtained a signature, then they would be able to brute force all the emails, be like, hey, does this match the signature? Can I get a message to match the signature, yes or no? And then they can brute force it.
Yeah. By brute force, he means just like changing, like they just be like, does this work?
Yeah.
No. Does this work? No.
Yeah, exactly. Yeah. Like they can just try like every single possible to email that they know about, like, and check.
What is a ZK proof? Is it essentially something that like, is it like, it's like code or like a long string of scrambled words that is made because it's of something that has, there was a process and it's like proved something?
Yeah, so you can think of a ZK proof as like some like basically like 6 very long numbers.
Yeah.
And it's like this number can vary, it can be like 100, it can be 4, whatever, but like some sequence of very long numbers, such that when I apply a specific operation on these numbers and these numbers, I get to this number. And only if I can only generate these numbers, and also I have UG and twitter.com. So when I combine like all of this information, I get this number at the end. And this number is impossible to generate unless you have these inputs.
I see. So basically it's just like a long line of some random scramble.
Yeah, what it looks like is just random scramble.
Yeah, and then generated through the process of all of that.
Yeah, generated to ZK email.
Basically a signature of message.
It's very similar to a signature in the sense that a signature is going, and this is why like this whole residency is around ZK proofs of signatures, is because like when you make a ZK proof of a signature, you can verify somebody said something and like redact part of it. So like I'm here making a ZK, I'm converting this signature into a ZK proof, and I can redact whatever I want.
Why is the residence called Signature Singularity?
It should really be called like ZK Signature is Great Residency or something. But like we just call it Signature Singularity because our whole shtick is like we found very cool signatures online. Like the fact that emails are signed is like a fluke. It's like somebody smart at Gmail was like, oh yeah, like we should probably have signatures. And then now we can use that to do this crazy redacted ZK proof thing. And then like Florent figured out, oh, passports have signatures. And so now what I can do is I can redact any information on my passport. I can like scan my passport and I can do this exact same process where like this is the USA's public key and this is like the signature in the header and the message is like my passport. And like I can now remove all the information except for like USA and like my age. And I can say, hey, I'm gonna prove that I'm like above 21. And I remove everything else.
That's cool.
That is the right reaction.
Yeah.
That's cool.
So it's like pretty insane. You can now do like shadow voting, right? I can say, hey, like I'm gonna run a fake election in US or Russia or wherever, where people prove they have a passport and now they can vote, but I have no idea who voted against Putin or something like that.
Oh, you can do that passport stuff.
Yeah, you can exactly do this redaction process and then prove it. And you could do it even on chain so that nobody can censor this. Like Putin can't go in and be like, nope, I'm shutting this down. I'm killing the person who runs it because they have to kill like all 1 million people who run validators.
It's the similar thing with like the chat board we were looking at, and like the chat board, and you can make sure like only people from like Stanford or like for like whistleblowing and stuff. You want to you want to check if someone's whistleblowing that they actually come from that company without revealing their actual emails, so they don't get in trouble or something.
So here's a good question. Let's say I want to do that. Like I want to prove to you that I work at like I don't know, like whatever, like
Gmail.
let's say I work at like waterloo.edu. Like I have a waterloo.edu email. Like what would I do here? Like what information could I like then redact to prove that I like work at I have a waterloo.
By redact, like keep or cut?
So redact means cut.
Okay, yeah.
So like I don't know, I have an email from like let's say I'm using the Twitter email to prove that I like have a waterloo email. Like to like
Oh well, you would keep your Gmail obviously on there, and then maybe.
Oh, so there's no Gmail. So I'm gonna take an email from like Twitter to my Waterloo email, and now what I want to do.
Sorry, I meant you would keep your waterloo.edu on there.
Yep.
And your name somehow.
Well, let's say you want to be anonymous.
Yeah,
Say I want to prove I came from Waterloo, but I'm not gonna reveal who I am.
Oh well, if your name is somewhere on there.
You can redact your name.
You can just cut whatever you want, right?
I'm so confused. Okay, everyone's Waterloo email is kind of available online, so I feel like if your like name was just in the body, and then if the waterloo.edu is on there, I can just easily put them together and verify that it's you.
Right. So that means I have to redact like the entire body. So I'm gonna get rid of this entire body, and this is now gonna be hidden.
Yeah.
And like this from, like it doesn't matter. You can keep it, you can leave it, whatever.
Yeah.
And then this, I'm gonna hide the whole thing.
Yeah.
And so now only Waterloo.edu is left. This entire rest of the email is gone.
Okay.
But I can still verify.
Oh, because the
that,
signature and the header.
Exactly, the signature in the header. I can verify that Twitter sent like Waterloo, like somebody at Waterloo an email.
Okay,
I'm gonna
that
remove
makes
everything
sense.
else.
I was like, otherwise there's no other.
Yep. What's up?
Hi, what's going on?
I'm explaining ZK email to designers.
Wow,
Yeah,
this is insane.
pretty sick. We did encryption, hashing,
Oh, like just cryptography.
cryptography. I did blockchain.
Blockchain.
Blockchain was pretty dope. Yeah.
Oh my god.
We have a story for you.
What's up?
We were wait, let's start from the start. Okay, we can start from the message.
It's getting streamed also.
Okay, start from the end so it feels
It's getting streamed, is
Okay,
that
okay,
what
okay.
Should we pause the stream?
Let's pause the stream.
Okay.
Okay, let's start from